Joo, it's a basic variation cake. Cake is just 4. This is peasant 4, villager 4. The 4 that you believe is the only 4. This carries no context. The dimension on all members must be absolutely identical. And despite this constraint, it's axiomatically accepted that numbers of this form, stripped of their units, are the basic argument of arithmetic operations. Which is absolutely impossible nonsense. That's a contradiction. That's a contradiction of terms right there. Like, you just set up like a liar's paradox, basically. Like, why are you doing this? You don't see this? Okay. Binomial cake. So this is the string of coefficients, 1, 2, 1. Okay. The basic unit spell out for a quadratic, it looks like this. There is, this should not be the same as this. So that is, as far as this goes, that is, we can consider that to be a typo. But I put it like this so that it's more familiar, right? We normally think of these coefficients as a, b, c. A squared, or ax squared, bx, c. But these are defining the units for each of these. And this too, it's not really, it's not a kekkan kok. It's not that kind of a 2. It's more a binomial kok, which we'll get to in a minute. Okay, so there's some lack of clarity here. Just that's not b being divided by 2. It's b housed within a binomial kok. It's different. So this is even further validation for why there needs to be clearer notation developed, because I can't actually even explain this. I can't explain this in the notation that currently exists. Okay, so this value, just ignore that that there's a division by 2 indicated there, right? The b, whatever that coefficient is for the linear term. The real component of the parabola, or of the roots, so this is like the axis of symmetry of the parabola, is negative b on 2a. That 2 right there, there's a reason for that, right? It's housing the b. B is walled up within 2, or we have b per 2. Recall when I mentioned that per means wall or house. Yeah. Q is C on A, and there's apparently no numerical coefficients here because coefficients of 1 are just ignored. And this causes problems. This causes problems in classical notation because, for instance, the reason that nobody can figure out why 0 to the 0 should be 1, other than that's the only value that seems to actually work, so let's just set it there because that's the only one that works, right? Nobody can come up with a principled reason for why, because the coefficient of 1, your initial reference frame for exponentiation, is always just thrown away when your exponent is positive. So it's never recognized that that 1 that you're throwing away with a positive exponent is the same 1 that when you have a 0 exponent you're getting as a result. Or it's the same 1 that you're getting as a numerator when your exponent is negative. Like, nobody's put this together somehow. But everyone's going to say that I don't understand. Okay. Now, so this x right here, is going to be the real component plus or minus the imaginary component, which is the square root of q minus r squared. Now, if we divide x by 0 by setting a to 0, notice that these all have a in the denominator. So if you set a to 0, this ends up being a division by 0. Or if you look at the standard quadratic formula, there's a 2a in the denominator. If you put a equals 0, the whole thing gets divided by 0. Either way you want to think about this, if we set a to 0, we're dividing x by 0. Now, if we do that, we get the linear form 0b1c1. These 1s are the binomial kok. Okay, this is the 2 that it comes from but the binomial theorem, right? So these are our exponents with respect to y, right? So this is by plus c equals 0. It's that linear equation, right? Now, y is x on 0, which is the same as negative c on b, which is the same as q on 2r. The context of binomial gig thus allows us to do something that we otherwise cannot. For example, when q is r squared, r on 0 is r on 2. They are the same thing. We know how to divide r by 2, and in this case, that is also how you divide r by 0. In other conditions, it will be other things. So division by r remains generally undefined. Okay? And this only works if our reference frame involves binomial gig. This is one of the reasons that it's worth developing a notation to indicate when binomial gig is at play. Okay? Also note that the basic unit spell out for the linear equation is binomial gok. I've already mentioned that. Similarly, basic unit spell out for the cubic is binomial gig ek. For the illiterate amongst you, gok is 2, gek is 4, geg ek is 8. Non-gok ek. So you can also get 4 with hama, vike, gok. And these are just vectors that are being batch processed, commutatively batch processed. So the order of them doesn't matter, and the result of this is summation. So there's no actual, there's no binary operation here. There's no binary operator. Okay. Here, the star is indicating iterated summation. So it's still not an operation, really. But the result of it is effectively multiplication. So we can sum 2 and 2, or we can multiply 2 and 2. Either way, we get a kind of a 4. These are all distinct from each other. These 6 are all distinct from each other. These ones all have context. I don't know the value of these contexts. I do know the value of this context, or at least part of the value of this context, and why it should be preserved. So here, like up here, when we're looking at this, and this binomial gig turns out to be the same as a gig, and this binomial gig turns out to be the same as a gig, and this binomial gig disappears because the gig, the contextless gig, eats itself, it disappears, it annihilates itself. This context remains important because with this, we can do a division by 0 if we're careful. If we handle things correctly, we can manipulate this and get real meaningful divisions by 0 out of this without ever touching limits. Right? Like, this is an absolute magic trick compared to what conventional mathematics is doing. But everyone out there is like, oh, you don't understand how numbers work. I think I might. I think I might understand how numbers work. Perhaps slightly more than you do.